There are also absolute value inequalities. Absolute value inequalities with a less than symbol will always give you a between statement. Absolute value inequalities with a greater than symbol will always give you an or statement. Before we begin, there's a few things we need to go over from Algebra 1. Less than or greater than symbols have an open dot. Less than or equal to or greater than or equal to use a closed dot to represent that the solution also includes that number. If we divide by a negative, you flip the inequality symbol. Example 3, the absolute value of 3x minus 4 is less than or equal to 8. When we have a less than or equal to symbol with absolute value, we write our problem to work like this. The 3x minus 4 just comes out. Both of these will be less than symbols. On the left-hand side, this will be negative 8. On the right-hand side, this is positive 8. So what is inside the absolute value symbol comes out exactly the way you see it. On the left-hand side is the negative piece. On the right-hand side is the positive piece. Both inequality symbols are less than when we're talking about less than or equal to. Now we treat this just like an equation. So I have negative 8 is less than or equal to 3x minus 4 is less than or equal to 8. We need to isolate x. Since x is between the two inequality symbols, I'm working from the inside out. To begin, add 4 to all three sides. X is still not by itself. 3 is multiplied to it. So to undo 3, divide everything by 3. So all three pieces get divided by 3. This leaves negative 4 over 3 is less than or equal to x is less than or equal to 4. The preliminary answer would have had this between negative 8 and positive 8. But now that we have solved, our answer is between negative 4/3 and 4. So our answer will be written in interval notation, negative 4 over 3, comma, 4. These are brackets because these are less than or equal to inequality symbols, both of these. Number 4, the absolute value of 6 minus 2x minus 10 is greater than 4. Now we have a greater than symbol, so this looks a little bit different. We want to isolate the absolute value. To do that, we need to add 10 to both sides. Now, the absolute value symbol is isolated. Now, the greater than symbol is just a little bit different than the less than symbol. With greater than, I treat it just like I would the equal sign. I have one equation that is going to be less than, so I pull this out exactly the way I see it. 6 minus 2x, that will be less than negative 14, or 6 minus 2x is greater than positive 14. Notice this just comes out. The 6 minus 2x just comes out exactly the way it is. We do not change any of these numbers. The first one will be negative 14, and we will flip the sign. The second one will be greater than positive 14. The preliminary answer is either going to be less than negative 14 going this way, or greater than 14 going this way to the right. Now I solve each individual equation. On the left side, we will subtract 6 from both sides. Negative 2x is less than negative 20. Now divide both sides by negative 2. Remember, when we divide by a negative, we flip the inequality symbol. So now x is greater than positive 10. On the right-hand side, we have 6 minus 2x is greater than 14. Subtract 6 from both sides. Divide both sides by 2, negative 2, and x is less than negative 4. Remember, when we divide by a negative, we flip the inequality. The graph of this equation will look like this. X, I did make one error. This is an open dot because these are less than or greater than symbols, not equal to. So therefore, X is greater than 10. This side is greater than 10. These numbers are greater than 10. And this side is less than negative 4. So we write the answer negative infinity to negative 4. These are both open brackets. Union 10 to positive infinity. Example 5 is an example of a less than symbol. So we already know that we will be using less than symbols here and here. This piece comes out exactly the way we see it. On the left-hand side is the minus part of it. On the right-hand side is the positive. The preliminary graph to this would be negative 2 to 2. Now let's solve. When I isolate x and get it by itself, I'll subtract 3 from all 3 pieces. Divide by negative 1 on all 3 pieces. And because we're dividing by negative 1, the inequality symbol flips. So we have 5 is greater than, x is greater than 1. These are never written with greater thans. They are always written with less thans. So I'm going to take this equation and flip it around. 1 is less than x is less than 5. You should be able to read 1 is less than 5, and that should sound correct. So this looks good. And now when we graph it, this is going to be 1 to 5. These are both open dots. And it's all the points in between these 2 points. So any point that I put in for x that's between 1 and 5 will be a solution to this problem. And we write this in interval notation 1, 5. Let's check this and see. 3 minus x is less than 2. We said our answer was between 1 and 5. So let's choose 2. Better yet, let's choose an answer that we know is not an answer, 0. If we plug 0 into the absolute value symbol, we get 3 minus 0 is 3. And then the absolute value of 3 is less than 2. Well, the absolute value of 3 is 3. 3 is not less than 2. So therefore, values on this side of 1 are not a solution. Let's plug in a value on the right hand side. Plug in 6. 3 minus 6 is less than 2. 3 minus 6 is negative 3 is less than 2. The absolute value of negative 3 is positive 3. Again, this is not less than 2. So everything on this side cannot be an answer. Let's look at 2. That's numbers that are in between 1 and 5. If we plug in 2 in for x, we get the absolute value of 3 minus 2 is less than 2. 3 minus 2 is 1, so the absolute value of 1 is less than 2. Well, 1 is less than 2, and that is a true statement. Any number that we put in that's into the equation between 1 and 5 will be a true statement. This concludes day 1 of absolute value.